Today we are going to look at Chemist Paper 2 questions and answers. Kindly subscribe. The grid given below represent part of periodic table. Study it and answer the questions that follow. The letters are not the actual symbols of the elements. What name is given to the family of elements to which A and C belong? Noble gases. Write the chemical formula of the sulfate of the element D. The sulfate of element D, that is it. Which letter represents the most reactive metal? Y. Which letter represents a non-metal? Is what? It's E. Non-metal, it's E. This. Name the bond formed when B and H react. B and H, when they react, what's the name of the bond, and explain your answer. Ionic bond, because B reacts by losing an electron or electrons which are gained by H. If you talk about transfer of electrons also, you can get the point. Transfer of electrons from metal to non-metal. Question 5. Select one element that belongs to period 4. One element here is D. You can select D or M. Ionic radius of element E is bigger than the atomic radius. Explain. Ionic radius of E. Because E reacts by gaining an extra electron which reduces the electrostatic pull by the positive nucleus, making the ionic radius increase. Or you can say incoming electron causes increased repulsion. Electron configuration of divalent anion of element N is 2.88. Induce the position of element on periodic table drawn above. At period 3, group 4. The oxide of G has lower melting point than oxide of L. Explain. G and L. G and L. So the oxide of G has a lower melting point than the oxide of L. Explain. Because of the increase in the strength of the molecular bonds in the oxide of L as compared to that of G. 9. How do the atomic grade of 1 and C compare? Atomic grade of 1. Compare 1 and L. Compare. C as smaller. 1 and C. C has smaller atomic radius than 1 because of the increase in the strength of the nuclear force of attraction in C as number of protons increase. 10. Explain the trend in fast ionization energies of elements J, I, and L. The trend J, I, and L. Fast ionization energies increase from J to L across the period due to addition of an extra proton in the nucleus, increasing the attraction of the valency electrons. Question 2a. Define the following terms. Saturated solution, a solution that cannot dissolve any more of the solute at that particular temperature. Fractional crystallization, scientific technique used to separate substances due to their differences in crystallization temperature. Solubility of salt X and Y were determined at different temperatures as shown in the following data. Temperature in degrees Celsius, and then solubility of 100 grams of water, X and Y. On the grid provided, plot a graph of solubility, which is the vertical axis against temperature. From the graph, determine the solubility of each at 50 degrees Celsius. So this is it. 3. At what temperature was the solubility of both salts equal? 5 degrees Celsius. 4. What is permanent hardness of water? It's type of hardness that cannot be removed by boiling. The flowchart below illustrates two industrial process, Haber and contact process, each here at one of the starting materials and other chemical reactions. Give the name of the process by which air is separated into oxygen and nitrogen. It is called fractional distillation. Apart from oxygen and nitrogen gas produced from process A1, A1 is this. Apart from the oxygen and nitrogen gas produced in the process A1, name any other gas produced in the process above. We have argon, neon, xenon, krypton. Name the substances which are represented by the letter A, B, C. A, B, and C. A is sulfur, B is ammonia gas, C is sulfur 6 oxide, C, and D is ammonium sulfate. Ammonium sulfate. Name the catalyst used in Haber process. Finely divided ion. The contact process is vanadium 5 oxide. Explain the role of the catalyst in both the Haber and contact process. The catalysts fasten. The Haber and contact process by lowering the activation energy of the reactions, or the rate of production is increased. Write a balanced equation of formation of compound D. Compound D, there nitrogen per process, then D. This is it. This is it. Calculate the percentage by mass of nitrogen present in compound D. This is how you do your working. Give one use of compound D, it's used as a fertilizer. A student set up an arrangement below to prepare and collect dry hydrogen gas. A student set up the arrangement below to prepare and collect dry hydrogen gas. Zinc granules, heat, dilute sulfuric acid. Identify two errors from the section of the arrangement showed above. The outlet delivery tube should not dip into the sulfuric acid mixture in the round-bottomed flask. 2. The use of heat is not required. Complete the diagram to show how hydrogen gas can be collected. This is how you complete it. Wet hydrogen, the cardboard. Explain why hydrogen was collected by the method shown above. It is denser than air. Write a balanced chemical equation for the reaction that takes place when hydrogen gas is burnt in air. A. Determine the relative atomic mass of C given that when was used 6.54 grams of C was used, 2.4 liters of hydrogen gas was produced. The molar gas volume is 24 liters. That is how you make the calculations. State any two non-industrial uses of hydrogen gas. It is used in balloons by meteorologists and it is used as a rocket fuel.